In Chapter 4.3, you're going to be looking at how to work with some special properties of exponents. So we're going to start out by looking at some tables, seeing what you can observe so that you can discover these properties on your own without me having to tell them to you. So let's get started. In the first table, we've got a series of products of powers. Our first power is 3 squared, and that's times 3 to the 5th. So when we write that in expanded form, 3 squared is 3 times 3. 3 to the 5th is 3 times 3 times 3 times 3 times 3. And we're multiplying those two together. Well, that turns out to be one big old multiplication problem. 3 times 3 times 3 times 3 times 3 times 3 times 3. And if we're really paying attention, we recognize that as the expanded form of 3 to the 7th. So let's do a few more. 4 cubed times 4 squared. 4 cubed is 4 times 4 times 4. And we're multiplying that times 4 squared. 4 times 4. So we're expanding each power and then writing it as one multiplication. 4 times 4 times 4 times 4 times 4. Well, that's just the expanded form of 4. And then what's our exponent? How many times are we using 4 as a factor? 1, 2, 3, 4, 5. 4 to the 5th power. Okay. Continue on. 7 to the 4th times 7 to the 4th. So 7 times 7 times 7 times 7. There's 7 to the 4th, and we're going to multiply that by 7 to the 4th. 7 times 7 times 7 times 7. Whoops, excuse me. So that leaves us with 7 times 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 7. We're using the base of 7 as a factor 8 times 7 to the 8th. Okay. I want you to go ahead and finish 5 squared times 5 to the 4th. Show each step. And then I want you to answer the question below. Explain how you can use what you discovered. So pay attention, look at the patterns, see what you can figure out. What is the rule when we have a product of powers, when we're multiplying two powers together? Notice what's the same about every problem. Notice what's different about every problem. Notice what the product looks like when we write it as a single power. Where did those numbers come from? So, how would you explain how to use what you discovered, what you're noticing, to write 2 to the 7th times 2 to the 10th as a single power? Now remember, explain means you're going to write me directions. You're going to explain this to me in words, in complete sentences, using some good math vocabulary. All right, let's continue. Let's look at another table. Again, you're going to be very observant, see what's happening, and your job is to discover the rule that has to do with when we have a division of powers, or a quotient. All right, here we go. First one, 3 to the 6th divided by 3 squared. Notice we've written it as a fraction because every division problem is a fraction. And then if we write it in expanded form, 3 to the 6th, 3 times 3 times 3 times 3 times 3 times 3, over 3 squared, which is 3 times 3. Now what happens here? We can simplify this fraction. We can cancel off a 3 in the numerator and a factor of 3 in the denominator. And what are we left with? In the numerator, 3 times 3 times 3 times 3. In the denominator, we would have 1. So in other words, it's just 3 times 3 times 3 times 3, the base of 3, and it's used as a factor 4 times, which means 3 to the 4th. So let's keep going. 4 to the 5th over 4 cubed. 4 to the 5th in expanded form, 4 times 4 times 4 times 4 times 4. And in the denominator we have 4 times 4 times 4. Then we're going to be able to cancel out some of those factors. And we are left with 4 times 4. Oops, excuse me again. Which is the base of 4 being used as a factor 2 times, so 4 to the second power, or 4 squared. Alrighty, we'll do another one. 5 to the 4th, 5 times 5 times 5 times 5. That's being divided by 5 cubed, which is 5 times 5 times 5. We can cancel out some factors of 5, and we're left with 5. And if we want to write that as a power with an exponent, that's 5 to the 1st. Alright, now you're going to go ahead and finish out 8 to the 7th divided by 8 cubed. And then you're going to be really observant. What is the same about the problems? What's different about them? When we write them as a single power, where are we getting those numbers from? And so hopefully you can figure out what the rule is when we're dividing with powers. And you're going to explain for me in words, using sentences and great math vocabulary, how to use what you've discovered to write 2 to the 10th divided by 2 to the 7th as a single power. Alright, and for our last example, let's look at this table. This time we're taking a power to a power. Alright, let's see what happens here. 3 squared cubed, 3 squared to the 3rd power. So our base is 3 squared, which means we're going to take 3 squared as a factor 3 times. Let's expand it. 3 squared is 3 times 3 times 3 times 3 times 3 times 3. Alright, so we're taking 3 squared and we're going to expand it. And what do we end up with? We've got the base of 3 being used as a factor 1, 2, 3, 4, 5, 6 times 3 to the 6th power. Example number 2, 2 to the 4th squared. 2 to the 4th as a factor 2 times. 2 to the 4th times 2 to the 4th. Now we're going to expand that. 2 to the 4th. 2 times 2 times 2 times 2. We're multiplying that. 2 times 2 times 2 times 2. So we have a base of 2, and it's being used as a factor 1, 2, 3, 4, 5, 6, 7, 8 times 2 to the 8th. Alright, go ahead and you try 5 squared squared. 5 squared as a factor 2 times. So go ahead and complete that, and then walk down here and explain for me how to use what you've discovered to write 4 cubed to the 2nd power. Write it as a single power. So again, observe what's the same about each problem. Observe what's different. Take a look at when you write the power as a single power. How does that compare to how it was written when you had a power raised to an exponent? So, be very observant, see what you come up with, explain it using complete sentences and great math vocabulary.